In this lesson, we're going to talk about graphing inequalities in an xy coordinate system. So let's say that x is greater than 3. You know how to graph it on a number line. But what about on a graph with an x and a y axis? X equals 3 is basically a vertical line. Now, x being greater than 3 but not equal to it, instead of drawing a solid line, we're going to draw a dashed line. Because x is greater than 3, we need to shade towards the right, towards the large x values. And so that's how you can graph it. Because it's an inequality, there's a range of answers, so you have to shade the appropriate region. So now let's try another one. Go ahead and graph this. X is equal to, it's less than or equal to -2. So whenever x is equal to a number, it's going to be a vertical line. And because it's less than and equal to, we're going to draw a solid line as opposed to a dashed line. And less than is towards the left side. So the numbers that are less than 2 is going to be towards the left of 2. And so you have to shade everywhere to the left of this line. Now let's say if y is greater than -4. How can we graph it and where should we shade? So whenever y is equal to a number, it's going to be a horizontal line as opposed to a vertical line. And because it's greater than but not equal to, it's going to be a dashed line instead of a solid line. The numbers that are greater than -4 are above this line. So we need to shade in this region. And so that's it for this example. Try this one. Let's say if y is less than or equal to 2. So this is going to be another horizontal line at 2, but because it's less than or equal to, it's a solid line as opposed to a dashed line. And because it's less than, we need to shade below it rather than above it. And so this is the answer. Now what if we have an equation with two variables? Let's say that y is greater than x minus 2. How can we graph it? So this equation is in slope-intercept form. The number in front of x is the slope. So if there's no number, it's 1. And the constant that you see on the outside, that's the y-intercept, which is -2. So the first thing we're going to do is plot the y-intercept. And then use the slope to find the next point. If the slope is 1, that means that rise over run is 1 over 1. So as you go up 1, you need to travel 1 to the right. So up 1 is the rise, 1 to the right is the run. It's 1 over 1 because the slope is 1. So therefore, the next point on the graph is here. The next one will be here, and so forth. Now, it's greater than but not equal to, so we're going to draw a dashed line through these points. Now notice that y is greater than the function, so we're going to shade above the line rather than below it. So everywhere above it, we're going to shade. And that's how you can graph it. Let's try one more example. Let's say y is less than or equal to 2x minus 3. So we can see that the slope is 2, the y-intercept is -3. Let's go ahead and graph this function. So the y-intercept is -3, and the slope is +2. So let's start with -3. Now, because the slope is 2, that means that the rise is 2 and the run is 1 because 2 over 1 is 2. So we need to go up 2 units because the rise is 2 and travel 1 unit to the right because the run is 1. That will take us to the point 1, -1. Then if we go up 2 over 1, that will take us to the point 2, comma 1, and then 3, comma 4, and so forth. Now, because it's less than or equal to, it's going to be a solid line as opposed to a dashed line. And because it's less than the function, we need to shade in the region below it. Another way in which you can determine where to shade is by using test points. Let's choose 2 test points. The first one being the origin, 0, 0, and another one, let's choose this point, which is 4, -2. If the equation is true, then you should shade in that region. If it's not true, do not shade it. So this should be not true if we plug it in. So let's replace y with 0 and x with 0. So 0 is less than 2 times 0 minus 3. So is 0 less than -3? On a number line, it's not. 0 is to the right of -3, and any number to the right is greater than the numbers on the left. So this is not true, which means that we should not shade in this region. Now let's test the point 4, -2. Let's replace y with -2 and x with 4. So 4 times 2 is 8. 8 minus 3 is 5. So is -2 less than or equal to 5? Well, -2 is less than 5. And if we read it the other way, 5 is greater than -2. Both ways you read it, it's a true statement, which means that we should shade in a region that contains that point. So now you have 2 ways in determining which is the appropriate region to shade. You can use a test point, or you can use the fact that the equation says y is less than or equal to 2x minus 3, which means that you should shade below the line.